last week, first of all, we're going to start off today with a couple of items where we talk about, like in your standard practices. I need you guys to really. There's a couple things here. All right, everybody needs to get out of the habit. If you're in the habit of when you're working on the airplane, do not set stuff on top of the engine. It's a bad idea. It's a bad habit to get into. If you're up there working, and like the Malibu out there is a real nice one. You got a nice little work area up there with the baffles. Same way with the Cirruses. You got those baffles up there, nice big baffles, all kinds of room to lay tools and hardware and whatever. Get out of that habit. You got to make yourself get out of the habit of leaving stuff on top of the engine. Okay. It's just a bad habit to get into. Something can get bumped, can drop down into a spot where you just don't even see it. You miss it. It's just a big safety issue. There's a 182. When I was in Virginia, living up there, somebody had went somewhere, had something done. 182, they left a wrench, 7/8 wrench. Well, I don't know what it was. We only say it was a 7/8 wrench just because they had messed with the spark plug or something. 182 took off. That wrench managed to come out of the cowling on takeoff and came out and went out and hit the prop and ended up having to do an engine tear down because it damaged the blade root enough to where it counts as a prop strike. You got to pull the engine off. So they found the wrench or ratchet, whatever it was, but that was a long time ago. But anyhow, so it's just bad habit to get into. Don't leave stuff on top of the engine. It's not a work table. Have your little work table or something beside there to keep all your stuff on. And then hardware. Does everybody realize on these nuts, most of the hardware nuts have two sides? Does anybody ever notice that?
Like a flat side.
Mm-hmm. A lot of these nuts, one side will even not even be really this flat. Sometimes it'll kind of go like this. It'll be even rounded more like this, And then the other side will almost have, when they look at the nut, it's almost like they came in here and welded a little washer to the bottom of it where it's flat. Okay. And then the other side up here, it's kind of exaggerated, but it'll be more rounded. It's not. I didn't bring one in here, an obvious one, but pay attention when you put these nuts on. Okay. Some of them are super important and critical that you can do that. Some of them, like when you're putting on just even a little 1/4-inch nut holding a 8L clamp, a cush clamp together or something, doing something simple as that, it's not that critical. But pay attention when you always look and just try to look for that side of the nut and put it on right every time, whether it be a vacuum pump, fuel pump, 5/16, 1/4-inch, all those will have that like almost like there's a washer welded down here. Take the time to look at it and do that every time, and then that way it'll eventually just become habit forming when you're putting these hardware on the nuts to where you look at it, where you cylinder hold downs, everything. It's critical, it's critical to get them on there. Another thing you'll run into that's back here doing the cylinders on Continentals. Does everybody know what the 7th stud is on the Continental cylinders? Has anybody been through that yet? Y'all know what the 7th stud is? So on the Continental cylinders, Continental decided that you got the big stud, big stud, big stud, big stud. 2 of these will be through studs, right? Y'all know what anybody know what a through stud is?
Mm-hmm.
What's a through stud, Patrick?
It's like a long stud that extends through the casing.
Yeah, that stud's going to go all the way back to the other side of the engine back here, and it's going to come through a cylinder on the other side. Okay. And then when we torque those on, it's real important. Like if we pull one cylinder off, you're not just invading this one side. If it's the middle cylinder, you're going to have to pull exhaust and induction and everything off the other side of the engine to get to that nut on that other cylinder. And we just don't go there and hold it. We actually take that nut off, we oil it up, we clean it, we oil it, just like this one. We put 50 weight oil on it, and one guy's over here torquing the 50 foot-pounds or whatever the torque is, and the one guy's over here torquing 50. Simultaneous torque on those through studs. Very imperative. That engine will come apart if you don't do that. It will come apart. So, but back on this Continental, so they got 8 studs. They're usually 1/2 inch. These will be like 3/8 studs, 9/16 wrench size. These will be usually 3/4 in wrench size, but they're 1/2 inch diameter. Okay, so Continental added this 7th stud. Okay, don't know why they call it 7th stud, because there's 8 and then boop boop. Don't know, but somebody a lot smarter than me figured that. But they've got a little clamp over here that holds this. Well, this stud, the nut that goes onto this clamp to hold this 7th stud, that's a different nut. It's got a nut like this, okay, and it's actually conical on the bottom. That nut is actually got like a dish, because the little bracket that goes into here that holds it down, that hole is recessed. So if I had to show that clamp from the side, okay, here's a side view, that it's recessed. That 7th stud comes through, okay, comes through this. Okay, this is the cylinder base. This is where it comes out. That nut is conical. It goes down into that spot there. It's not flat like this. Doesn't have a washer type anything. It's actually conical. So that's one thing. If y'all are doing Continental cylinders and you got the 7th stud, you got this other bracket like any 550 out there now's got, whether it's the P-bear in the back, it's the Cirrus up here in the front, they've all got this extra stud now. Okay, pay attention when you're doing that.
That nut is designed specifically
just for that. It's real obvious if you mix, and it's the same size as these. It's these 3/8. It's the same size. So if you just take all the nuts off and aren't paying attention, you put them in a bucket and you put them back on. I've seen cylinders come in where this nut would be on here and it's obvious. You look at it and you're like, holy shit, there's a gap underneath of it. And then you figure out what they did was, when you take this one off, it's got a flat one on it. It's got a flat nut, one of these flat nuts on it that are sitting there, so it's not dropping down into the conical spot. So pay attention to your hardware. Hardware's critical. Anything, whether it's be the wrong hardware, the hardware's on backwards, the side that can cause a relapse in torque, where the torque gets compromised, it's bad, especially when it comes to cylinders. Okay, cylinders are super critical. Accessories, fuel servos, carburetors, fuel pumps, vacuum pump. You don't get a vacuum pump torqued on right, you got a huge oil leak. It's bad. So pay attention to your hardware. It's real important. Okay, and then the other thing is, just don't leave your hardware in the tool and stuff like that. Tool sitting on top of the engine. And since we're on it, you'll see you may still see an occasional Continental come in where they use the exhaust nuts. There's what's called a spiralitalic nut, and then we don't use those anymore. We use just plain old these stainless nuts. But this is also what you call a blow-proof gasket. That gasket is perfectly fine to reuse on these engines, whether it's Lycoming or Continental. That one, it's got the 4 holes. You'll see it's almost, that centerpiece is kind of is captured inside the outside part. You can see how it's kind of captured in there. Okay. Yeah, see that middle part? It's captured in there. As long as it's not damaged, like see this one's getting borderline. We probably want to replace that one. But you can take that, you can put those on the wire wheel and clean them up and reuse them. As long as that inside part isn't starting to come apart.
Are these directional?
No, those are just called blow-proof gaskets. Continental's got a bulletin talks about it. Lycoming's got a bulletin talks about it. They're totally reusable. Okay. Exhaust flange, yeah. So I've heard both ways. I've heard do it and It I've always done it just because I had an old guy that I learned from Virginia, and then when I got up here, an old guy I learned from it, and it does make a difference. It does. It's because if you got a brand new engine and that's a brand new cylinder and that surface is perfect and the exhaust flange surface is perfectly perfect and flush, everything's brand new, you probably don't need it because that is actually soft. That material inside is soft. It can make up some imperfection. But if you've got even a 200-hour cylinder and parts, I always put the RTV on there. Just a small bead. You put it you fit the big thing about exhaust is, especially turbocharged exhaust, you want to fit everything. You always do a dry fit first because you're just you can be highly unlikely that everything fits perfectly. So you have to get Marmon flanges to line up just right. So you want to dry fit everything first, make sure you don't have something way out of whack. Okay. If you can see that everything's going to work, and you tighten everything together, you tighten your clamps, you tighten your Marmon flanges, you tighten your V bands. You got to just tighten everything all together at the same time, and everything will usually work. But that's when you take it apart. You go and put a bead RTV on both sides, just a real thin bead, and you go up there and just hold off on your torque. Go up there, run it up. It touches. Give it about 15 minutes. Let that high temp RTV skim a little bit, just like if you're using it on putting it on rocker covers, like Chevrolet. I don't know what Chevrolet does now. It used to be they didn't even use gaskets. That's all they used was this RTV. They used in there for gaskets. You put it on there, you bring it up on almost to the point where it torques, where it's torqued, but let it skim. Then you torque it. You let the stuff heat up, just like using PRC on fuel panels. When we do PRC on fuel tank panels, you put the PRC on there, you run it up, you just let it up there. You don't tighten it all the way down. You let it set. If it's a B1 an hour PRC, you want to come back in about 20-30 minutes after you go up there, let that stuff set up a little bit, then torque it. That way, because if you put it up there when it's super wet and you go torque it, all it does is just push all the PRC right on out. You're not making a gasket anymore. You got to let that PRC set up to where it's actually okay. Now it's skimmed. It's got a nice layer all the way around it. You got to let it skim partially hard. Then you come back and tighten all the screws. Because when it's wet and you're just going up, you're just going metal to metal. You're just going to push it all out of there. So.
What does RTV stand for?
Room temperature vulcanizing, I think, something like that.
Okay.
So, or I don't know. It's some term like that. Somebody a lot smarter. Look it up. It's because and then PRC stands for what is it? Look it up. See what it says.
Yeah.
Is it? Yeah. So and then PRC's got another what all that stands for. That's like kind of that's a tough one to remember.
What does PRC stand for?
I don't know.
Okay.
It's a different type of sealant, and it's a weird. I never can remember the technical.
Temperature vulcanizing makes sense because the vulcanization process is
People in public
it's a setup process. Vulcanization is when you put it's like epoxy when you take that out into the oxygen environment, it causes a reaction. It causes the molecules to cross-link and set up.
Yeah.
Okay. So it's basically the start of the chemical reaction. It happens at room temperature.
Mm-hmm. Yeah. Yeah. And then PRC is another that with the materials in PRC, it's a little different. It's another term that's used. I can't remember that one. But yeah, so these are perfectly fine to reuse. Just clean them up and just make sure there's not any pieces missing out of them. The stuff's starting to, because if you have an exhaust leak, it's a good chance that one of these may be starting to burn up and not going to be able to reuse it. So, but to answer your question, Mike, there's numerous gaskets. That one, like I said, it's got you got your housing that holds it, but inside, that if you look at it, that the sealing part actually sticks out of it. It's thicker. It's thicker than this CAD plated part on the outside. So This is what's actually doing the sealing, these parts here. So eventually they'll get, if they've got a bad enough leak, they'll erode. And on these, when they're brand new, you can still see the lines. If y'all notice that, you can see the lines in there. And you can see how this one isn't really protruded.
Every time I would look, I would kind of like see if it kind of bulges out
Yeah.
a little bit.
See how that one's almost down to the surface of the CAD? There's
The inner piece will bulge out a little bit more
Yeah.
than the outer piece.
Yeah. That one looks like it's almost gone. It's almost flat.
So the inner piece is softer metal
Yeah.
than the outer piece.
Mm-hmm.
So it's designed to compress a little bit and fill in the gaps.
Yep.
Right?
Yep. Yep. Yeah. But they'll say you can reuse them. You know, they're reusable, but you need to look at it. You just don't take it all. Oh, it's just reusable. But if it's starting to wear down and to where this is gone, it's just this where it doesn't look like it protrudes anymore. You know, if it's starting to look where you don't have it coming in, then yeah, it's time to go
When I
around.
worked at ATP, every time a plane would come in with RTV on the exhaust, they would get so pissed off. What idiot puts RTV on the exhaust?
I've heard it'll cause a leak. The ones with black with the numbers. I was told, oh, if you don't put the numbers up, you know, you guys are lying and stuff.
Yeah. Yeah, the RTV it's not going to cause a leak, if any, but it's like anything when we do the exhaust, whether you use the RTV or not, after you do your ground run performance check, you always retorque it. Always retorque your exhaust. Pretty much anything you do, because in the induction, you know, your induction pipes, you know, you got your induction pipes, you know, some of them are 4, some of them your pipe comes out, you know, you got your bolt here and you got that gasket. And that gasket's now going to get hot, and that's going to cool down, you know, well over half the time, unless you torqued it to 120 inch pounds instead of the 95 inch pounds. You're probably going to need to retorque it, you know. And then a lot of times, you know, you're still going to need to retorque it. It's going to get hot and cool down. You just got to retorque it. So just anything you did is just as a good habit, and to check stuff, and you want to make sure your stuff is going to stay right where you left it and ride for a good 100 hours. You need to do your retorques on anything that you had off: vacuum pump gasket, exhaust, induction, carburetor, anything, that because that engine's now gotten hot and now it's cooling down for the first time. Guarantee it's going to change. You're going to need to retorque it. So
We run, we had to wait for a little bit of time and
you ain't gonna have to wait, because by the time it gets back in the hangar to where you can retorque it and cowl it, it's gonna be cooled down anyhow. You know, so yeah.
You guys know why that's true?
Expansion, contraction.
Coefficient of linear thermal expansion.
There you go.
As you heat up, the metal expands, right? Cools down, it contracts.
Mm-hmm.
Every metal has a different coefficient, so depending on whether it's aluminum or steel or whatever else, it'll expand and contract at different rates.
Mm-hmm.
I'd always get like an extra quarter, eighth of a turn every time I go to retorque it.
Dissimilar metal like aluminum has 3 times the coefficient of thermal expansion that steel does.
I don't think you need to do that, just because these guys are pretty smart. They figured out the torques and what you should torque them to. The engineers, and if you torque it per that range that they say, I think they've got that figured in. You know, so if anything, I would say if there's a range, say if it's 95 to 110 inch pounds, I would torque it to the 110. Okay, and then when it comes back in for the retorque after it's gone, I'd go to the bottom end. You know, because you've already hit it the bottom on after the run up. Because if you torque it to the higher, if you want to just stay in the middle, stay in the middle. It's fine. You know, it's just every time is going to be a little bit different. You know, how you torque it. Maybe when you were torquing it, the torque wrench the flex socket had a little bit of turn on it or something. It's just you know, just pay attention. That's where it's like the devil's in the details. Pay attention to how you're torquing it and make sure you're not up against them when you're torquing it. And then, but it's just always safe to do a retorque, because I just know from past, if you don't retorque that induction, you know, after it runs one time, You come in here then 50 hours from now and do oil change. If it's a carbureted engine, you may start to see a little bit of fuel or something coming around that gasket, little fuel stains where it's just not sealing right, you know. So just let's get into the habit of retorquing stuff. Everything we did after the run, just good practice.
I remember I was at ATP and they were really pushing on torquing the exhaust risers evenly. You don't do it evenly, you just crank one all the way up and then the other one's still hanging down. I guess it'll bind them because they apparently had one of their mechanics did that and a plane went and flew and all the risers broke off. And the whole exhaust was just sitting on the cowling.
You talking about torquing left to right all at the same time?
Yeah.
Yeah. Well, Lycoma's got a bulletin that tells you when you're installing exhaust, and especially turbocharged exhaust, they want you torquing everything all together. They want it all up in place. They want you to hit the risers. They want to hit you the turbo transition, the V-band clamps on the Marmon flanges. They want you to go and torque everything together, you know, because of that reason, you know. And then on the other one that's a pain is like, you guys probably have seen this, is like, okay, so here's a Lycoman looking up at a Lycoman exhaust, okay? You know how they've got two holes, right? And you got your pipe right here, okay? Well, by the time you put your nut on out here, a lot of times this nut is like right up against this pipe. You know, your socket, you can't get your socket on here because it's up against the pipe, especially if you go and tighten. So this is why another one, you snug this one up a little bit and you come in here and snug this. If you just tighten this down, then you come over here and you put this nut's right up against there. Now you can't even get your socket on it. So you need to loosen this a little bit and just to shift that pipe a little bit. So that's why you want to go up together a little bit at a time to snug. That way you still got a little bit of clearance in here where your socket will fit in there. So that's just something you learn over time. But I mean, it should be like, well, dang, how come I can't get this socket on here? Well, just step back and look and see why you can't get it on there. It's like there's a little bit of play because, you know, the hole that the exhaust stud's coming through it's got a little bit of play in there. You know, it's probably maybe got, you know, 50 thousandths on either side if you so it can move. Yeah.
Sometimes they welding is a little bit cut right then.
Yep.
Catches.
Yep. So.
So when you got that kind of advice from ATP, was that part of a formal training program, or was it?
No, it was just in the field, just working.
Part of their manual or something, or how did you learn?
You kind of work with someone shadows you.
Okay. Okay. So they didn't have like a formal training program for new people coming in. You just started working with.
Yeah, you just get shadowed by someone the whole time. I think it's like 1 week. 1 week period. But because it's the same plane.
Yeah, I mean, you're working on two airplanes. You're working on two airplanes. You're working on a Seminole or Archer.
Yeah. It's like
72.
Okay. So let's go over the fuel, doing the fuels. So basically, Continental and Lycom got the two different fuel. When y'all are doing the fuel systems, like on okay, for this backup point, say we got a carburetor down here. I don't know if I can draw damn carburetor or not. Okay. So the carburetor, you know, it's going to have a, you know, when your lines, when you do your oil, your service items and all, you know, you've got your fuel screen. So Lycom and Continental, either one, when you're doing the carburetor, you're always going to have a fuel inlet screen on the carburetor. We got to check, okay? So you've got that screen. Imagine if everybody here done a carburetor yet to where you got to take this fitting out. You take the fuel line that's going in, or the fuel hose that goes in main to the carburetor. You take it off, and you pull that fitting out, and there's a screen attached to that fitting, right? All right. So on fuel servos, like on a Lycoman, if y'all recall, the fuel servo, the fuel line going into it, it's kind of the same thing. You've got that fitting. you got that fitting that goes into the servo, okay? Here's your servo base, and then there's an O-ring in here, right? You got that O-ring on that fitting. You take that fitting out of the servo, and then but when you take that fitting out, y'all remember what the screen does? What can y'all do with the screen? The screen on the fuel servo fitting. Do y'all remember what? You can actually take it out. Yeah, that filter comes out. Okay. Yep. So that's a little bit different. Usually this one, the screen just stays on that fitting. When you take it out, you just got to look in there. You got to try to blow it out. Usually got some lint. I don't know where the lint always comes from in fuel systems. I don't know. That's just crazy. It's just weird. You look in there, the lint builds. It's a yeah, I know it's right.
A lot of times, we'll end up taking out from the wrong side of the fuel servo.
Yeah.
We'll end up taking out from the back side.
Yeah. Yeah. So what Philip's talking about, once we get the screen up here, we can show more pictures of it. But yeah, on the fuel servo, you'll have an inlet. Okay, you'll have your inlet fitting here. Like I say, it's got an O-ring under it. But over here, they'll usually just be, a lot of times there'll just be a plug that gets safety wired or something, you know, the plug. But over here, you've got the fitting. Okay, you got the fitting that comes out of here. Then your B-nut goes onto that, right? So when you take this out, you know, like I said, you've got your fitting and you've got your screen that goes in there. Okay, and then this has got a spring back here. And you got an O-ring here, right? You got an O-ring here and you got an O-ring here on the base. So if you take this out, the plug side, you know, back here was just a plug, and it's going to have the same O-ring here as this one does. If you take this out, you'll be looking at the spring here, and it's a little more difficult. That's why we always want to try to take the fitting out that's usually got the B-nut on it, that's got the fuel hose. You got to take the B-nut off that attaches there. Yeah, you want to take the inlet side out. Yeah, you want to take the inlet side out, and then that way you can pull this thing, because this O-ring, once you get it out, I don't know if I've gone over it with you yet, but there's usually a hole right here in this screen. So say this fuel's coming in here, this is usually all the way up in here. This is hidden inside of here, okay? And then this part is actually inside of this fitting in that hole, okay? And there's that O-ring sealing in here, sealing that up. So all the fuel going in, it goes inside this filter and then comes out of this filter into the housing and up to the carburetor. So any fuel goes inside of this filter and then comes out. Well, what happens is, the whole idea is, if this were to clog, the pressure would build up. It would go against this spring, and that's when this part would get pushed back enough to expose that hole, and then you just got unfiltered fuel going through. At least if this is clogged, at least you've got fuel coming out going into the servo that's unfiltered. At least might just at least start running rough if it clogs up a fuel nozzle instead of just shutting off if this didn't do this. So you got to be careful, because this will go in backwards. This will go in the wrong way. So, but what will happen is it'll just be blowing by here all the time. You just have unfiltered fuel all the time. This will actually go in backwards. So pay attention. Just when you take it out. That's what I say, because sometimes it's a real pain. It may be a lot easier to pull this end out to get to it. And the only problem is, if you pull this out, you don't know if this is dropping into here or not. If you don't know if this piece is actually going inside of the fitting, this little piece here.
You feel that over.
Yeah.
Go right on the fitting.
But if you're just trying to push it in from this way, you can't really tell if this filter is going in that housing fitting. So on fuel servos, for the Lycomans, the RSA servos, always pull the inlet fitting out when you're doing it. Okay. So that's important. And then when you get to Continental, all except for the like the P bearing back there, the P bearing engine, and the engines on the Seneca 4 and 5, which has got the Continental engines, but it's got an RSA servo just like this. Any other Continental, you know, you got your fuel control down on the, usually on the bottom of the engine, like on the Bonanzas or the Cirrus will be up on the top. They the Cirrus doesn't even have a fuel screen, does it? Up there on the engine? No, there's none at all.
You just have that gascolator.
Yeah, it's just on the ships, on the ships, you know, the gascolator. But like on the Cirrus, there's nothing. The fuel goes into the fuel engine driven fuel pump, goes the boost pump engine driven, and then it just goes up to the engine. There's no inlet screen. But at least like on Bonanzas and Barons, you got your fuel control. Like on the Bonanza, you got your fuel control down here on the bottom of the engine. You got all your arms off here off to the side, and you've got a your fuel line. You'll see your inlet fuel line where it attaches to this fuel control, and then right, sometimes it's off the bottom, sometimes it's off the side. There'll be a big nut there, and there's a screen you take out and clean. Okay, so that's going to be like where is it? Yeah, so on your service item where it says servo carburetor fuel screen, inspect and clean, that's just, you know, that's on the Bonanza, it's down there underneath the engine. On the Barons, it's back there on the back of the engine. Same type thing. You've got this fuel control unit, and you've got that nut, which actually it's if you were to pull it out, it's a big nut, and it's kind of like almost the carburetor screen. That screen is attached to that nut when you take it off, and you always want to change that gasket out underneath of it.
Yeah, that's a beach part number. The gasket.
No, it's Continental part number.
Oh, but yeah, for that.
Yeah, Continental.
Black one.
Yeah, Continental part number for that thing. It screws into there, and it usually gets safety wired. So, but that's kind of like the carburetor one. It's when you pull that nut out, the whole screen comes with it. If you take it out and the screen stays in there, you're like, oh, there's something, you know, that's something's wrong. Just like on these carburetors, if you pull that fitting out of the carburetor and that screen comes off, there's something wrong. It's not supposed to. They're usually the screen is usually silver soldered into that fitting. So
Talking about screens, the oil suction screen. If you don't put it in there right, and you start tightening, it'll crush that screen. Do you want us, if it does happen, you pull it out, would you rather have us straighten it?
Yeah, you can straighten them.
Or would you rather just replace it?
You can straighten them, because what you're seeing is, you know, my drawing sucks. All right, so here's your sump on the outside. Okay, like on the this is your sump. Inside of the engine, on the Lycoming, there's a tube there's a tube in here. Okay, and then this tube then works its way up to the oil pump. I mean, it goes straight to the oil pump. Okay, and then what you're doing on that Lycoming, you've got the nut out here that's actually it's got a recess in it. You know, here's the threads out here on it, but inside this is recessed. Okay, and that you've got this screen, this copper looking screen. You know, it's got all the holes in it. If y'all anybody pulled the suction screw out?
Yeah.
All right, so that actually goes into here. Okay, that goes into this big nut. All right, this has to go inside of there as well. All right, so unless you're on an engine that's like there's tons of room right here, you want to put this. It's easier to just slide this into here, but as you're going in, you got to be super careful. And you're feeling that this is actually going inside of here, and it's snug. It's a snug fit. This fits right in here pretty snugly because of it. Huh?
It's hard to drive.
Yeah. Well, you know, because you can't get this started. And then if you got a Mooney like an M20J or an E or F that's got that 200 horse engine in the back, This is right up against the firewall. So then what you have to do is you have to take this, you have to go through the hole, get this started in there. Just put this on your finger, put that into the hole, and you'll feel this when it drops into that hole. It just starts to drop into there. Then you can start this. This will have just enough sticking out of the hole here to where you can then wiggle this over top of that and get it all together at one time. Because if you just kind of force that in, this will bend, you know. And if it bends and it goes short, now you're sucking unfiltered oil up to the oil pump. You won't notice any problem, because if this is, as long as this goes up and tightens, and you tighten down on that crush gasket and seals, it's not going to have an oil leak. But if you get this in here and it's bent and it's not sealed, you're just sucking in unfiltered oil. And if there is, say, they've got this designed where all these little holes, they figure any piece of metal that goes past this hole, that size, it'll go through the oil pump without causing any damage. But now if you somehow leave this out or you bend it, now you've got a big gap here. Now it's just sucking in unfiltered oil. The corner of a lifter breaks off, which Lycoma, it does happen. They'll break a little piece of lifter off. If that gets sucked up in there, that's going to take that oil pump out, and boom, your oil pressure is gone just like that. You just wasted the oil pump. Your oil pressure is gone. So, so that screen on the Lycomans, be careful. Some of them screen comes right up the belly of the airplane. It's down here on the bottom, and it's easy. You just pull the screen out the bottom, put it in. Continentals don't have this. Well, they've got it. It's inside the engine. You can't service it except on the IO360s, the little 6-cylinders, like on the SR20s and Seneca engines, stuff like that. You can pull this out and change it and clean it just like on a Lycoma. But anything else, 520s, 550s, all that, you can't get to it. It's behind the accessory case, and there's nothing you can do to get to it. It's built in. And oh yeah, and this is usually magnetized too, where you want to look in there when you pull this out. This has got a magnet, so if it's anything chunks of ferrous metal, it'll be stuck in there. So design. Yeah. So it's weird. Some of them, I don't know. I've seen some with or without. So, but a lot of times they'll be magnetized. Magnet, which is kind of weird because you wouldn't think it'd be on there. Mm-hmm. Yeah. Yeah. But yeah, that's your suction, your oil sump screen. And then on the Continentals and on these gaskets, the gasket that goes underneath of that, you know, there's you got your gasket that you put on the nut there, you know, you pump them through. So there's a split. Y'all notice on those copper crush gasket, there's a split.
Like right on the middle.
Yeah, you can see the material inside of there. There's a split in that copper gasket. You always put that split in the gasket. It goes towards the engine, like the part you're tightening to. Like that's always going to go towards the engine. Lycoma's got that in their SSP section for the Torx. They always put that. Now, I always like to put just a real thin coat of either Permatex number 2 or the purple jelly on there for a Continental. It helps it seal it better, because sometimes there's the torque, sometimes there's just a amount of rotation. You put it on and it touches, and you go like a quarter turn, half turn. Yeah, they'll usually have a degree rotation on it. So, but always put that opening, that split, towards the engine.
So we put a little bit of a tape.
Just a little thin layer on it. It helps. Like I say, it's maybe some little imperfections in the surface that you're taking up. Like some of the old Continentals, the 470s that don't have an oil filter yet, they've got a pressure screen here on the back of the engine. Okay, goes down into the engine, and the screen, this big old thing like this, and the pressure screen. If you still have these, they want you to change the oil every 25 hours. But the top for this thing, it's got a big old nut on it, and it goes down, and it's got a big crush gasket, one of those big crush gaskets here. And you put oil in the engine. I mean, there's always oil sitting right here to this point. There's always oil. So if you don't put a little bit of Permatex on that crush gasket on this one, when you put that in, it's going to leak. Guarantee it's going to leak. So, okay. So back on the fuel system. So on the Continentals, yeah. So on the Continentals, sometimes there's really not much to do. Like on the Cirrus, there really is no fuel screen to do on that, except on the. Yeah, no, I'm sure there just isn't one where the Beechcraft and Bonanzas, those are, they've got that fuel control to the side. They've got that screen to clean. Yeah, and then so what was on this last thing?
I was gonna say, cleaning those screens on the servos, because if the fuel goes inside and the screen kind of tapers in, you don't get a flashlight in there and kind of like pick it out. It'll always be there, all that junk. You know what I'm talking about?
Like on what engine?
On the fuel servos, the RSA, those screens, how like if you look inside, the screen inside actually tapers in. On the outside, it's like a tube. Some people would just spray it down.
Oh yeah, yeah. You can. Yeah, you want to. That's what I say. If you, I've seen people actually just go in there. They just take the have gas on it, and they'll strike a match to it and just woof, and you'll see all that. You'll see all the. If you go inside, you'll see the lint in there just go. It just kind of goes up. That's why, like, if you take a little small 90-degree pick and go inside that filter and run it, you'll see the lint come off it. Yeah. So it's good. I don't recommend putting that lighter in there later, but I've seen people do that, and you'll see the lint just light up in there. It's crazy. I don't know what it's from, but if you at least take the air hose and blow around the outside of it, you can get that lint and hair and stuff, whatever, out of there and blow it out. So what was I going to say? We're going to talk about spark plugs for a second too while we're here. And then fuel system tests. Like, since we're on fuel system, one thing in here what we talk about is when we pressure test the fuel system. When y'all get your fuel system back together, make sure like your bottom spark plugs are out, okay? Because when we do the pressure test the fuel system, like for fuel nozzles and whatnot, you're actually going to let it run for a second. You're going to hear and make sure you hear the fuel going out to the nozzle, so it's going to be dumping into the cylinder. So what's going to happen? You're going to have a bunch of fuel going into the cylinder, and if you've got the bottom spark plugs in, it's just going to stay in there. Now you got a bunch of fuel stuck in the cylinder, and leads may be on, which is just a bad idea to have in the hangar. Somebody's got a P lead off or something. Now you got a cylinder full of fuel, and somebody bumps the prop and that thing hits. It's just a bad idea. So during the service, let's make a habit of, when we go back in with the spark plugs, it's a good idea to put the tops in. Okay, leave the leads off, leave the bottoms out, paint a coat of oil on the threads on the bottom plugs. That way, because if you leave the spark plugs just sitting on the table, you know what's going to happen. You already wire wheeled the leads, they're going to get rusty. So paint some oil on the threads for the bottom spark plugs. Leave them out until we're actually ready to, hey, let's get this thing out and go. Let's hit the bottom spark plugs in, torque them up, put the leads on, and go run it. And then that way, when you do your pressure test, that fuel will just come right out and drain out of the cylinder too. It'll get onto the ground. And then if it's one that we need to motor over to get oil pressure, do that after you do your leak test. That'll motor it over. That'll push any excess oil out of that cylinder too. So, and then talking about spark plugs, what's the proper spark plug socket to use for spark plugs? Not size. 12-point or 6-point. Why? If you take that, if we had one in here, I'll show you. If you put this 12-point on a spark plug, okay, so a spark plug can take all kinds of abuse. Okay, obviously, because what? It's like cylinder compressions can reach, the pressure inside a combustion chamber is extreme, right? If it goes into detonation, it's even more extreme. So it can take all kinds of abuse in here. You can clean it. You take the detonation can happen for a while before it starts shedding pieces, internal pieces. It cannot take any load this way or that way though. It is extremely hard. Everything about the spark plug is extremely hard. The case, the inside, the porcelain down here, the center part. It's just it is super brittle, which means it does not want to go this way. So when you're doing spark plugs, it's important to use a 6-point because that 6-point socket, when it goes over it, it's making more contact with this whole area right here. Okay. Whereas the 12-point is making less contact, and you're a lot when you take this spark plug on the spot, it almost, if you watch it, it goes on and boom, it's there. It's like there's very little movement. You take this 12-point spark plug you on there, it'll do like this all day long.
I've seen so many debates online saying that 12-point and 6-point have the same amount of.
No. If you get a spark plug, you can look at it. Try it next time you got a 12-point, 6-point. There's hardly any movement like this. So when you're tightening or loosening, you're not getting. It's not because there's not much distance. You can look in there. There's not much diameter difference between here and there. So if you get on here sideways too much, this socket gets on the top part. It can really load it up and crack it internally. You never know it.
Why does a 12-point even exist then? Why do we have it?
Because I think it gives you benefit of the angle. Sometimes you 6-point you can't get that angle, but the 12-point you can a little bit, yeah, you can suck in there and turn it.
Well, I mean, yeah, you need 12-point a lot of times just to be able to get it on in a certain spot, or it gives you ability to get it off and reposition it. Lower torque.
PT6 has 12 points.
So
Yeah.
everybody's generally got both in their toolbox?
Mm-hmm.
Okay.
Yeah.
But I would recommend buying a spark plug socket from Aircraft Tool Supply. No, ATC.
It's a magnet there that holds them so they don't drop it. Is it not? It's not hold there.
One up. They got a magnet.
Yeah, even it has
Does
a
it?
magnet.
This one doesn't have a magnet.
One of them has a magnet.
Snap-on doesn't have a magnet.
I think the Aircraft Tool Supply has
Well,
a
you're
magnet.
paying for it.
This one's got the little ring in there. The ring is supposed to help grab it. It's got the little, so if they don't want to put a magnet, because it's not a good idea to use magnetized tools on engines. But this little ring goes in there and pops through the hole just enough to help grab it and hold it.
Steve, is spark plug damage that's caused by that back and forth type of wiggling, is that pretty apparent?
No, what happens is you won't see it until it gets hot usually, and then if you don't have an engine monitor, it's almost impossible to figure out which one it is, because what you got to do is if you just feel an intermittent skip, it's usually a spark plug, and you can start isolating it by swapping the lead, the plugs left to right. But the only way to really find it is the engine's good and hot. You snatch out the plug real quick and get back to the spark plug tester, put it in there and get the pressure on and look at it. And if you got a blue spark and you see occasional just orange flash past that blue spark, that's when you've got that. You've got a break or something down in that insulation and it's hot. But you do it. It happens all the time. I mean, it's not uncommon to find it. If you wait until like when we're doing the 100 hour, and the next day you don't clean the spark plugs till the next day, and the spark plugs are cold, you never see it. You know, a lot of times it goes. You only see it when it's hot. You know, so
the biggest type of damage you'd see is crack in the porcelain, right? Or insulation.
yeah, you look in there. I mean, the fine wire plugs will go, you know, 1,000, 1,500 hours as long as they're not abused and have a lot of detonation going on. They'll last a long time. So then you're like probably harder to find it because they've got that much time on it, and but I mean, yeah, you want to look in there for damage. Obviously, when you're doing the 100 hour, look for visual problems. You know, loose electrode pieces missing. Obviously it's no good then. But to find an intermittent one that's just kind of, you get that skip every now and then, it's hard to find unless it's hot and you got it into that tester and pressurizing it. Just it's really hard to find. And if you got an engine monitor, you can kind of see it. You know.
So you mean even we do test it when we service the spark plug, you can find what's wrong with it.
You may not see it because it's cold. But that's why when you're testing it, and you're looking in there at the color of the spark, you want to see a steady blue, just steady blue. If you've got a blue and you just keeps getting orange flashes when you're testing it, there's something wrong with that plug. You know, starting to break down.
So how about it? That thing can jump back and forth.
Yeah, it's supposed to. You want to see it. If you see it jumping, if you got a massive electrode spark plug, okay, and you've got, it's got this, this type setup, and if you see it jumping, sparking and jumping, I mean, that's good. That means you've got the gap set really close. If all you're just seeing is just right there, it probably means that this is a good bit closer than that one. Is what that means. So, but on the, like on the fine wire, you've only got that one electrode, and this thing comes in from the side. Comes in from the side. And you got that one little road, so you've only got that one little gap there on that one. So.
I assume this would be more evident in a 4-cylinder engine than in a 6-cylinder engine, just because you have less amount of firing going on and less spark plugs. One of them's bad, magnified.
Yeah, and like I say, it's hard to, unless you've got an engine monitor. Like if you find you're on both, even if you're on both, even though you've got that one spark plug, you got another spark plug opposite from it that's still firing at that engine. I mean, you can still feel that one spark plug going in and out, even if the other spark plug in the cylinder is firing. You can still feel it, like like on a twin or something. Now, you can sit there and just put your hand on the tip. You can on the wingtip, you can feel if there's an intermittent. Yeah, you can just feel that intermittent hitting, and you're like, there's a spark plug somewhere.
So occasionally, like we'll hear planes, man, it'll be like thumping or kind of popping when the engine's running. Is that what's causing that?
Well, at idle, if you hear like the popping and stuff, that's usually just a mixture or something wrong. It's just usually lean, kind of lean. They tend to pop and stuff. But this, you don't really notice it until you get up on the power. Like at a mag check, if you were to just leave it on, if you had like a nice engine monitor system there, and you go to left mag, instead of just going left mag, yep, good, right mag, yep, good, leave it there for a second and watch what happens. And because it'll eventually, that cylinder will eventually start trending down, because when you do your mag check, your EGTs always will go up. When you turn one mag up, your EGTs always go up, if everything's working right. But that one cylinder, they'll go up and they should stabilize. But if you leave that on that one mag, and that one spark plug is the culprit on that cylinder, it should start trending down a little bit because it's misfiring. So, but if it's something weird like some kind of detonation or something going in there, it could actually go up. You just watch for that one cylinder to see what's going on. I mean, the EGT, if it's misfiring, it should come down. But you got to leave it on long enough to watch it. Yeah, if you, huh?
So we had to watch the EGTs.
Yeah, yeah. Okay, and then not every airplane's got a good engine monitor. So then you're like, yeah, I mean, it's hard to find. Engine monitors are worth their weight in gold in troubleshooting.
Can you talking about the difference between the EGT and TIT? So
EGT and TIT.
they should be together or just one?
So when do you what's TIT mean?
Repeat that, Mike.
Turbine inlet temperature.
Okay, so TIT and EGT. TIT and EGT. So when are you going to have TIT? When would you have when would you have TIT but you wouldn't have EGT? Turbo. So this is for turbocharged engine, okay? So this is for turbocharged. So and it's pretty common that with turbocharged now you'll have this and you'll have EGTs for each individual cylinder. You'll have if you got a 6-cylinder, you'll have an EGT for all these, and then some of the engine monitors you'll come over here at the end, you'll see a T, okay, on that engine monitor, and that's your turbine inlet temperature, okay. So your EGT, you're usually measuring. Say here's your exhaust pipe coming off the cylinder, the flange here, okay. So a lot of times they'll have you mount this EGT probe in here, somewhere between like 1 and 3 inches or something. The book will tell you where to mount it, okay. So every cylinder should have that at the exact same spot. I mean, within just fractions of a millimeter. You want that close because that probe, that much difference in one cylinder to the other. Say you got another cylinder up here. That's going to be 100. That's going to be 100 degrees. They'll tell you. You look in the book and they can tell you. You can figure out the difference in it. Okay. Because one problem we're faced with, these guys now get these nice engine monitor systems, and they'll come back and say, "Hey man, number 3's running at 1480, and number 5's running at 1500. Can you fix that?" You're like, "Really, man? It's digital. You would never see it if it was on analog gauge. Now you've got all this exact information. That's just like it's next to impossible." So EGTs are going to be reading right down here at the cylinder flanges. Okay, that probe sticking in there. The TIT is just what it means when it says turbine inlet temperature. You got all these exhausts, okay, coming back here. You got 1, 2, 3, 1, 2 on each side. Comes back here. Then you go back here. You got a transition back here. Okay, turbocharger sitting on top of here. So this is where you measure the turbine inlet, where the temperature goes right into the hot side of the exhaust. Okay. Some airplanes will have a left TIT, some will have a right, like on a Cirrus SR22T. They've got two turbos. They got a left turbo and a right turbo, so they're going to have a left TIT and a right TIT. Chieftain's going to have just one turbocharger, one gigantic one here in the back. So a Mirage has 2 turbos, but it only has one TIT because it in reality, you've got a transition right here for your wastegate, and you've got one right. Your exhaust go over here and goes overboard, but you've got a crossover, a balance tube that comes over here on the back of a Mirage, and your TIT is over here on this side. But in theory, with the wastegate, the TIT right here is going to be the same as over here with the balance tube and everything. So they just take one reading right there. The TIT is over here on the left side. So that you're just reading that temperature going into that turbocharger. That's what the TIT means. It's usually right there as it goes in. When you're like on the P brand back here, you saw that, but when they were loose, something's wrong. They're even the wrong probes. We've got to fix those. We've got to fix the probe back there. Get the right probe in there for one. So that's the difference between EGT and TIT. So
remember CHT.
Well, CHT is cylinder head temp.
So that one is installed into the cylinder, right? The CHT.
Mm-hmm. CHT is cylinder head temp. Cylinder head temp out of all of these, like you move the power lever, you move the mixture control, you're going to see instant changes on these. You're going to see these change real quick. CHT is going to be your slowest reacting of all the temperatures that you're reading. We don't have we don't have coolant, we don't have water, so there's no, you got oil temp, so we don't have any antifreeze out there, so everything's air cooled, so you're looking at oil temp. Basically your oil temp is your radiator compared to a car. But oil temp and CHT are going to be your slowest reacting temperatures that you look at. So you pull your mixture back, you're up here at 2200 RPM, you start leaning out, you're going to see your EGTs start to go up real quick. TITs go up real quick. This one, it's going to take a little bit, because this is going to be your slowest reacting temperature. That's why you don't see your cylinder temp is going into your cylinder head up here, right at the base of it. And there's your cylinder back here, all your fins. This is your top of your cylinder. It's usually right there at that point. So you don't. It's the CHT is slow to react, but the compression, like when the combustion chamber pressures in here, when you start leaning back, you'll hear people say, I tried to lean it out I got a bad mag check. So I just started leaning back on that mixture. Man, those pressures are going through the roof up there. Combustion chamber pressures going roof. If they're cleaning off a spark plug on a mag check at 2000, 2200 RPM leaning back, that thing is detonating in here, and that's how you're trying to clean the spark plug. But that CHT is going to be slow to come up. You're not going to see it. All this badness is going on in here. You're killing it, but you don't see it. You could hear it if you're out there and kind of listen. You could hear it, but it's just not a good idea to go high power and just leaning it back trying to clean off a spark plug. If that spark plug has got lead in it, they said, oh, it's got some lead on it, clean off. If it's lead fouled, if that spark plug's lead fouled, that it ain't going to do it. I don't know, you lean it up. If there's a chunk of lead in there, if you ever had one that's lead fouled, you almost have to take a pick or something and get it out. It's welded to there. That the odds are that's not going. It's usually oil is what's got it fouled. Somebody goes up, I got a bad mag check, and so the best thing to do if it's running rough, you hit it mag and it's just got roughness. Just go up on the power, leave the mixture right there, go up on the power, count to 5 seconds, and come back. Check it again. If it was oil, it's going to be cleared out. If it's still fouled up, it's lead, and you weren't going to do it anyhow. All you're doing when you're overleaning is all you're doing is just killing that cylinder. You're just damaging it even more. So, But and you'll go through all this. You'll sit there and just go. You can sit there for like 5 or 10 seconds, run there and just run that mixture, and just have that thing just going running rough and just running like crap. You're like, oh yeah, it's probably clean out good. That cylinder temp may not even move in that time. But that combustion chamber's gone up to like 4,000 psi or something ridiculous. It's just killing it, And you just, you're still not going to see that cylinder temp. What will happen is you come back on the power, and by then you'll start to see the temperature come up a little bit. It's just the slowest one to react. So, but that's your differences in the temps. EGTs are always usually right there. Now the old ones, if they had just like a single EGT gauge in the plane, you'll still see some airplanes come in where they've got just one gauge, just like EGT, and one that's CHT, and they've just got one probe. That EGT a lot of times will be somewhere down the line, like all three of these cylinders come in here. They might just put an EGT probe down here, downstream, down one side by itself. So if that's just like if they had the old gauge that had the arms on here, it's usually just one probe.
There are certain cylinders that run hotter than others.
Yeah. In a carbureted engine, the cylinder that's furthest away from the carburetor is usually going to be your leanest because it's got the longest run. That's usually going to be your highest EGT. And then if you have a cylinder that's got an induction leak, say that gasket, say you got a gasket up there leaking on a carbureted engine, that's all your air and mixture is getting mixed down here at the carburetor. When it comes through the carburetor here, that's where your fuel and your air mix together. Okay, so now it's got to go through the sump all the way up to all the way up to this one, and all the way up to this tube to go to the cylinder. So if you're like most of your Lycomans, you know, it's back here, so it's got to go all the way up to the front, like on a four cylinder. It's got a lot further run. So when it comes out of here, and you've got this gasket going to the bottom of the cylinder, and that gasket starts leaking, well, now that piston, instead of, when it goes down, instead of drawing air fuel in from this whole tube mechanism, now it's starting to draw air in from here. Okay, so that induction leak. So now you got just air with no fuel. Okay, so it's going to be even leaner. It's going to make it even hotter, make it run poor. So keep that gasket sealed. Now it's at least sucking here, but still it's got a lot further travel to go. So it's naturally that the cylinder furthest from the carburetor is always going to be the leanest. Where fuel injection, you know, you got your lines up there on the top, right? So on your fuel injection, say we got a Lycoman servo. This goes to the engine. You got your big diaphragm valve right here, air control. And then also on the Lycoman, you've got these tubes that come in. If you're looking in front of the Lycoman, they're called ram air tubes, and they go to this. There's this diaphragm on the other side. So as air comes in, I don't even know how to draw this. As ram air comes in on those tubes, it makes pressure on. So on one side of this diaphragm, you've got the ram air hitting this, causing this diaphragm to flex this way, the little teeny metering valve in here. And on this side, you've got fuel, basically fuel pressure. So as ram air comes in, it forces this way. This little needle valve goes in more, opens up or closes, I forget which way, but it's going to meter the amount of fuel that goes off up into, remember that flow divider up on top of the engine where all your lines go off to? You got your flow divider back there. Fuel flow divider that goes to your nozzles. So now that's why you don't have any fuel down in here to go through the induction system to the cylinders. You've got a fuel hose. So now they figured out that X amount of PSI up here, you know, as this diaphragm moves, the fuel goes up here and it goes right in on top of the valve. That way you don't have to worry about, you know, if you have like on a fuel injection system, if you got an induction leak up here at your flange on the cylinder, it's not going to run lean. You're just sucking in unfiltered air. But at the same time, the amount of ram air that it's sealing is affecting this too. So it could run lean, because if this piston is sucking air, it is drawing in X amount of air, and that's all resulting of the amount of air that comes in here, then that's going to change your fuel flow on this diaphragm as well, right? Okay, it's not just basically ram air coming in that's pushing it. It's how much the pistons are pulling in through the induction system, pulling in, and that'll change the amount of fuel moves here. So it's a lot less likely to run leaner with a fuel injection system than this.
It's amazing too how much fuel flow contributes to engine cooling.
Yeah, that's where a lot of you'll see a lot of them will say, once you start the engine, it tells you to pull back on the mixture to lean it. Well, if you've got the mixture set right, everybody usually wants at like right here at the airport here, you're 1,000 feet above sea level. When you pull back on that mixture, say at 800 RPM, you want to see about a 50 RPM rise. And if it's more than that, if you're at 800 RPM, you pull that mixture back and it goes up 200 RPM, that's rich. That's too rich. You are probably going to foul up some plugs. But and in that case, it'd be fine to lean it back a little bit once you started, and it says lean to max RPM. But it's looking for that extra little bit of 50 RPM rise, especially in the hot days, to help with cooling the cylinder at idle, even at idle and grind operation. you know. But yeah, air and fuel and oil is what these air cooled engines, you know, they call them air cooled, but it's using the oil to cool. It's using the fuel to cool as well.
We did an experiment the other day when we were flying to Pensacola in the Cirrus, and I did a climb without enriching the mixture, and the temperatures rose in the cylinders pretty quickly as we were climbing because you give it more power, right? And we did the same thing with the mixture full rich, and the temperatures didn't come up at all. So the fuel cools the engine big time.
Yeah.
It's amazing how much. I bet there's a 50-degree difference at least. Yeah.
The other advantage of the fuel injection over carbureted is what? Y'all should have learned this in EMP school. Efficiency, yeah. But what can you get with a carbureted engine that you can't get with fuel injection engine? A problem that can arise. Carbice. Yeah, yeah. And that's because all this fuel and air are going through, when you go through this carburetor, it's going through the carburetor here, through the venturi, and the fuel is coming out and getting atomized, okay? So the air can have moisture in it, right? So that moisture in that air can get mixed in with this fuel as it's getting atomized, and it can, with just the air, it's not really going to freeze up in here. It's going to get cold, but the fuel allows the water to attach to it and get to the sides of here and freeze up, and it'll disturb the flow. Okay, then you can't get the flow. The fuel ends up stuck to the ice and it can't get in. Okay, the airflow drops. Then you can't get that fuel mixture to the cylinder. You know.
I was running my 182 on the ground, and I finished running it. Went outside. I was like, man, it's got a leak somewhere. I touched the carburetor.
That's frozen.
Frozen.